Hello friends, this question is for the test series number 12 from subjects of network and topic name is two-port network. In this problem we have one circuit and we need to find the equivalent Y parameter. The equivalent Y meter is what we need to find out. So this circuit is actually a parallel combination of two-port network in which there is one network of which the circuit element are given in terms of admittance YB, YA and YC. Okay, this is my one network which is a which is in which the circuit elements are connected in the pi form. It is pi network. Okay, and there is another network. Of that network we actually know the two-port parameters. We directly know the Y parameter of this network, so there is no need of knowing the circuit element because we are directly aware about the pi parameter. And these two networks are connected in parallel. So what is the mean by parallel connection? In a parallel connection, if the two networks are connected in parallel, there both the ends are connected with the same point. So I'm just drawing it roughly. So it is could be the one network like this and another will be something like this. These two points are connected. So this is my connection. You can see that. So finally this will be my input side V1 and this will be my output side V2. So this is the actual connection of this circuit, in which we have a two network which are connected in parallel. So we already know the two-port network of this Y1, this network, and we need to find the Y parameter of the this pi network. So this is a pi network, standard pi network. We need to calculate the two-port parameter of it or Y parameter of this pi network. So we need to just apply the simple KVL KCL. So I can simply assume that V1 is the input voltage, I1 is the input current, and I2 is the output current, and V2 is the output voltage. So now if I may apply the KCL at node, let's say this node is V1 because this is my ground node, and so V1 is the voltage difference between this node and ground. So this node is basically have a voltage of V1. Similarly, this node will have a voltage of V2. So if I may apply the KCL at V1, so my I1 will have the two component. So I can incoming current is I1, which will be equal to the YA into V1 plus YB times V1 minus V2. I can rearrange this equation as YA plus YB times V1 minus YB times V2. This will be my first equation. Similarly, if I may apply the KCL at the node V2, so my I2 incoming current is I2 and outgoing current will be in the branch of YC and this is a branch of YB. So my I2 will be equal to the YC times V2 plus YB times V2 minus V1. I can again rearrange this equation. So it will be YB V1 plus YC plus YB times V2 I2. This is my equation number 1. This is my equation number 2. Now the rest is as usual. We know the standard equation of the Y parameter. I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So now compare the equation 1 and 2 with the standard equation. You will get the two Y parameter of the new network is YA plus YB minus YB minus YB YC plus YB. This is the two parameter of the second network. Let's name this as a Y double dash. So we already know the two-port network of the Y1, which is given by the question, given in the question itself. Okay, we already know the value of YA, YB, YC, which is given in the problem, and we know the two port parameter of the second network in terms of YA, YB, and YC. So now I just simply put the values of YA, YB, YC, and I will know the two port parameter of the Y parameter of the this pi network, and then my circuit is basically a parallel combination of these two networks, and we know that if two networks are connected in parallel, so their equivalent Y network is basically their sum of their network. If two two ports network are connected in parallel, so their equivalent Y parameter will be the sum of their individual Y parameter. So my Y parameter will be, I can write down here. So my Y total will be y1 plus y double dash, which we have just calculated. So it will be y1 is 0.14 minus 0.04 minus 0.04 0.09, it is given in the question, and then this parameter which we have just followed, just put the value of ya, yb, yc in the expression, so you will get the values as 0.44 minus 0.11 minus 0.11 and 0.277. Then your equivalent y parameters will be the sum of these two, that will be equal to the 0.58 minus 0.15 minus 0.15 and 0.36. So here your correct option is option C. Option C will be your correct option. Thank you.